Okay, let's talk in more detail about exponents. So, to begin with, say we have this relationship, x squared times x to the sixth. What's going on here? Well, x squared means we have x times x, and I'm just going to put a parentheses here. It's not needed, but let's just do it so we can differentiate it. And then f to the sixth means we have x times x times itself 6 times, x times x times x times x. So there's a total of 1, 2, 3, 4, 5, 6, 7. There's a total of 8 of these. So isn't that just the same as saying x to the 8th? And it is. So we could call this the rule of products, but it's kind of intuitive. So whenever you raise something with a certain base, so we call this the base. The lower number, we call this the base. So whenever you have something with the same base, raised to some power, let's say m, and you multiply it by something else with the same base, raised to a different power, n, all you have to do in that situation is add the exponents. Doesn't matter the size. Doesn't matter the size. It all works the same, which is essentially x to the 1,000 plus 2. Suppose we take and we divide two variables with the same base, and they have exponents. How do we handle that? Well, that's like saying, hey, why aren't we drawing? Don't know what was going on there. It's like saying x times x times x times x times x. That's 5 divided by x times x times x. There's 3 down here. Well, we can kind of split these up. And then we have 3 left over, or actually we only have 2 left over. Put them over 1. Because x times x times x times 1 is the same thing as x times x times x, the same thing as x cubed. And x times x times x times x times x is x to the 5th on the top. Well, we see that x over x is 1. This is like 1 times x over x is 1. X over x is 1. And we're left with x times x over 1. And x times x is x squared. So, what did we do there? Well, it's the same idea. This is also equal to x to the 5 minus 3 equals x squared. Okay, well, what about x cubed, quantity, raised to the 2 power? What's going on there? Well, that's the same as x cubed, not plus, x cubed, I'll use parentheses here, times x cubed, which we saw was x to the 3 plus 3 equals x to the 6th. But of course, another way to look at this is we have x times x times x times x times x times x. So it's like 2 of those, 2 x to the 3's. So this is like x to the 3 times 2 equals x to the 6th. Okay, so those are the rules of how you combine exponents. At some point, you're going to be on a test, and you're going to forget those rules. Well, here's what I want you to do. Just rationalize them yourself. Do it this way. Take 2, raise it to the 3 power, and square it. Always remember this. Now you want to try to figure out what that is. So you forgot this on a test and you're not sure. Is this 2 to the 3 plus 2 or 2 to the 3 times 2? Which one is it? So I want you to do this, and you know what the answer is. 2 cubed is 2 times 2 is 4 times 2 is 8, and that's like 8 squared, and 8 times 8 is 64. That's 3rd grade math, I guess. 8 times 8 is 64. So we know what the answer should be. It should come out to be 64. So just work it out. So you got 2 times 2 times 2 times 2 times 2 times 2 equals, looks to me like this is going to be equals 2 to the 6th. So it looks like this is the correct way to go. Whereas 2 to the 5th equals 2 times 2 times 2 times 2 times 2, which is 2 times 2, which is 4 times 2 is 8, times 2 is 16, times 2 equals 32. 2 to the 5th equals 32. 2 to the 6th equals 64. So you can figure it out this way. So, okay, what happens if there's more things in parentheses? Well, we can't simplify this anymore. A times x cubed. So let's think of this. Let's put some real numbers here. 3 times, let's say 5 cubed squared equals. So what does this equal? Well, in this situation, you need to think about what's going on here. This is like a x cubed times a x cubed. We could distribute out the a. So this is a times x cubed times x cubed equals a squared times x cubed squared equals a squared times x to the 6th. So you see what was done. The squared, each term in here needs to be squared. So the a needs to be squared and the x needs to be squared. So each term in here needs to be squared. We've got 3 squared times 5 cubed squared equals 9 times 5 to the 6th. And you could work out what 5 to the 6th is and multiply it by 9 on your own. Let's say we have x to the 4th divided by x to the 4th. Well, what was that? Well, we said before, that's going to be x to the 4 minus 4 equals x to the 0. Well, we know that any number divided by itself equals 1. So we just went and shown that x to the 0 needs to be equal to 1. So any number raised to the 0 power equals 1. For example, say you have x to the 4th divided by 10x to the 4th. Well, this equals 1 over 10 times x to the 4th over x to the 4th equals 1 over 10 times 1. Any number times 1 is itself 1 over 10. What happens if I have x to the 5th divided by x to the 8th? So the exponent in the denominator is larger than the numerator. Well, we work it the same way. X to the 5 minus 8 equals x to the minus 3. So x to the minus 3 is the same thing as 1 over x to the 3. Why is that? Well, think about it this way. I mean, you got x times x times x times x times x. You got 5 of these up here. You got 8 of them down here. X times 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 x, with 3 left over. So essentially, you can cancel all these out because they all equal 1. X over x is 1. So essentially, you have 1 over x cubed, or 1 over x cubed. You could think of this as times 1 over those remaining 3 x's. So now we're able to handle more complicated examples. So suppose I have 3 to the minus 2 times 2 squared raised to the power of 3. How do I handle that? Well, same way. We've got, oops, not 2. First we take the cubed of this whole thing, and each individual number is cubed. So 3 to the minus 2 cubed, 2 squared cubed. So this then is 3 to the minus 2 times 3 times 2 to the 2 times 3 equals 3 to the minus 6 times 2 to the 6th equals 2 to the 6th over 3 to the 6th. Now we can work this out in a number of ways. We could actually calculate with these what the top is and what the bottom is. And I use a calculator. That's approximately 0.088. Or I could write that 2/3 and go backwards with the 6. Put it back in the exponent, 2/3 to the 6th power. Maybe go to my calculator. Take 2 divided by 3. Let me put parentheses in here. 2 divided by 3. Raise that to the power of 6. And we get 0.888 approximately. Let's try another. A over 2 cubed to the 2 power equals a squared over, well, 2 cubed is 8. I could work that out initially, and then I could square it. So this is a squared over 64. But another way I could do that is I could do that a squared. So a is 1 times 2 is 2 over 2 to the 3 times 2 equals a squared over 2 to the 6th, which again is going to work out to a squared over 64.